All right, welcome back. In this episode, in this lesson, we're going to be talking about predicting and naming molecular compounds. In the last lesson, we were focused on ionic compounds with polyatomic ions and multivalent metals. And then before that, just regular binary ionic compounds. Molecular compounds are made of non-metals. They are made of non-metals. That are held together by a covalent bond. Unlike an ionic compound where electrons are transferred to form a bond, a covalent bond is where electrons are shared between atoms to form a bond. Why do electrons need to be shared? The reason is because both elements are nonmetals. Both atoms want to gain electrons. Molecular compounds form solutions that do not conduct electricity, in comparison to ionic compounds where the solutions do conduct electricity. This is a little bit of a diagram. We have two different atoms which come together to form a molecule by the sharing of electrons. This section here, where these electrons are shared, that is our covalent bond. If we go back to our periodic table, which I'll just go back a few pages here, recall that our nonmetals are all of the elements that are on the right side of our staircase here. These are all nonmetals. The ones that touch the staircase are metalloids, but in the following compounds, they're going to behave kind of like a non-metal. So everything on the right side of the staircase is a non-metal. The things on the left side, those are metals. You'll notice that these all, when they're part of an ionic compound, want to have a negative charge, except for silicon, carbon, and boron, which seldom form ions on their own. That's polyatomic ions. Here we go. When naming molecular compounds, it is important to know prefixes. Prefixes are the roots that come before the full word. So prefix comes before the name, or the name of each atom within these molecular compounds. The reason that we have prefixes is because it's difficult to predict how many of each atom are going to be present in a molecular compound. In an ionic compound, because anions form a consistent charge, and you can figure out the charge on a cation by the anion's charge, you can predict how many of each ion will be in an ionic compound, and so you don't need to inform the reader how many of each ion there are through prefixes. In a molecular compound, you need to tell the reader how many of each type of atom is present. To do that, we use the following prefixes. If one of a type of atom is present, we say that there is a mono prefix. The prefix for 2 is di. The prefix for 3 is tri. You can think like a triangle has 3 sides. The prefix for 4 is tetra. Once you passed 5, if you know the names of regular polygons, then you will know the different shape names and therefore the different prefixes. 5 is penta, like a pentagon. 6 is hexa. 7 is hepta. 8 is octa. 9 is either going to be nona or enea. And 10 is deca. This table of prefixes is found in your data booklet. If you take a look at your Science 10 data booklet, then you may be able to find it. I'm going to just quickly check to see if I have it loaded on here. I may or may not have it loaded. This is the front page. Here we go. Perfect. This is what your Science 10 front page data sheet looks like. And here's your prefixes for molecular compounds. So we've got both Ania and Nana on there for 9, as well as our other prefixes. So you don't need to memorize these. These are given to you on your data sheet. So make sure that you know where to find them. Just going to get back to where we were. Here are the steps for naming molecular compounds. First, you're going to name the first element. So the first element in this molecular compound is nitrogen. Oops, that's the highlighter. There we go. Nitrogen. The first element in this molecular compound is phosphorus. For us, I always spell it with O-U-S, but you can go with just a U-S because I think that's what's on your periodic table. Then you're going to name the second element with "ide" on the end. This doesn't mean that this is an anion. It simply gets the "ide" ending at the end of this compound. It's informing the reader that it's in the compound. So oxygen becomes oxide, and bromine becomes bromide. That's our second element. This is the first element reading from left to right, second element going from left to right. Nitrogen, oxygen. Nitrogen, oxide. Phosphorus, bromine, phosphorus, bromide. The first element doesn't get any sort of suffix or changing on the ending. Add prefixes indicating the number of atoms. So we have 2 nitrogens, so that would be a di prefix for the nitrogen. And we have 1 oxygen, so that would be our mono prefix for the oxygen. In the next molecule, we have 1 phosphorus, so that would be the mono prefix. We've got 3 bromines, which is going to get the tri prefix. Now we have to make a little exception to our prefix rule here, and I know that's slightly annoying, but the first element actually doesn't get the mono prefix. I'm going to make a little note here. No mono on the first element. Then you're going to combine the parts. So this is named di-nitrogen because the di goes with the nitrogen. Dinitrogen. I'm going to run out of space in this box. Monoxide. With oxygen, we don't write the O twice on mono. So it's actually just dinitrogen monoxide, not monooxide, but that's just because we don't put the 2 O's next to each other here. Because there's no mono on the first element, this compound is just phosphorus, tri, because there are 3, bromide. Phosphorus, tribromide. Again, the final elements get the ide ending, and then you put a prefix to indicate how many of each element is in the formula. There is 2 nitrogens, so it gets the di, 1 oxygen, so it gets the mono prefix. We don't put mono on the first element. Again, the first element does not get the mono prefix. CO is simply carbon monoxide, not monocarbon monoxide. You're welcome to write that again, but it is written below. So this is carbon monoxide. Hydrogen compounds are unique, and we don't actually name them with the prefix system. The naming for a hydrogen compound is a lot more similar to the naming for an ionic compound. So this H2S is not actually going to be dihydrogen monosulfide. We name it kind of like an ionic compound, where you treat the hydrogen almost like a cation, and it's going to be hydrogen sulfide. So hydrogen is not a metal. This is a molecular compound. Hydrogen is not a metal, but we name it without putting the prefix in. There are a few molecular compounds that have common names, and so that you're going to use those common names instead of using the prefix system. So we don't actually call this dihydrogen monoxide. Instead, the common name for this compound is water. This compound you could name with the prefix system, but we don't call it hexacarbon dodecahydrogen hexoxide. Instead, this is called glucose. This will come back again in the biology unit. This is the main product in photosynthesis, and it's a sugar molecule. Can do some practice. This is moving from the name to the formula, and this is going from the formula to the name. Take a look at the first one here. Silicon tetrachloride liquid. All right. This is telling us our state. Molecular compounds, we talked about this earlier, but molecular compounds could be solid, liquid, or gas, or even aqueous. Whereas our ionic compounds are going to be all solid at room temperature. So we didn't have to worry about this state as much because we could just put the little s in brackets. For molecular compounds, it's important to name the state because it could be any of these. Silicon tetrachloride liquid. I'm going to work through these and just put the symbol below. So silicon, we can find that on our periodic table as Si. There is no prefix, so no prefix, which means 1, because we don't put the mono prefix on our first compound, our first element in the compound. Silicon tetrachloride. Tetra is 4, and chloride will be Cl. So the formula for this molecular compound is going to be Si for silicon, Cl for chlorine. We have 4 of them because we have the prefix tetra over here, and it's liquid, so it gets the little L in brackets to indicate its state. Let's do a few more of these. So we'll do one that works from the formula back to the compound. If we look in this formula, there's only 1 sulfur, but there are 3 oxygens. 1 sulfur, 3 oxygens, and this G indicates it's a gas. Our first element gets named as is, so just sulfur. It doesn't get the mono prefix because it's the first element, even though there is 1 of them. The second element gets its name changed to the "ide" ending. So this is sulfur oxide. But we need to tell the reader how many oxygens are in this sulfur oxide. So we do that with a prefix, sulfur trioxide, because that's our prefix for 3 over here. Because we have this 3, we know that we have to have the prefix tri. And we should say the state. This is sulfur trioxide gas. Working through this next compound here, we have diselenium trichloride liquid. Di is the prefix that means 2. Tri is the prefix that means 3. Selenium has the symbol Se, and chlorine, which comes from our chloride, is the symbol Cl. So this formula is going to be Se, it's di, so we have 2 of those. Cl, 3. It's tri, so we have 3 of those. And it's a liquid, so we can put the L in the brackets to indicate our state. This will be the last one that I do. We've got Se, Te, 2. There's 2 telluriums, which will have the prefix di. I'm just going to open up my periodic table so I spell telluride correctly. Our first element is selenium. It doesn't need a prefix because we don't put the mono prefix on our first element. Our second element we have 2 of, so it gets the di prefix. Ditelluride. It gets the ide ending, so tellurium, which is Te, gets its ending changed to ide because it's the second atom in this compound, and the state is solid. Once you get used to doing molecular compounds, you'll be tempted to start throwing prefixes into ionic compounds. There's a lot of good practice on the next page, actually a couple pages from now. But one thing that you want to make sure that you do is don't use prefixes on ionic compounds. So the first thing that you should be doing is trying to figure out, do I have an ionic or a molecular compound? If it's ionic, you don't need prefixes. If it's molecular, you do need prefixes. The way you figure that out, I'll talk about on the flow chart in just a moment. We have a table of common molecular compounds and their uses. Some of these are important for you to remember. You should know that water is not pronounced dihydrogen monoxide or just hydrogen oxide because it's a hydrogen compound, but just water. H2O2 is a common disinfectant. It's also used in hair bleach, as it's written here. If you're naming hydrogen compounds kind of like an ionic compound, where you just say hydrogen and then whatever this anion would be, then you'll actually find peroxide is in your table of polyatomic ions as O2, 2-. So you might actually come to the name hydrogen peroxide on your own. Ammonia, NH3, another hydrogen compound, but we don't call it nitrogen trihydride. It is instead ammonia. Common name to look out for. A couple other ones on here. Hydrogen sulfide down here again. This one is named just like you'd expect from a hydrogen compound where we don't use the prefix system. So instead it's just hydrogen and sulfur, it becomes hydrogen sulfide. Ionic versus molecular. Is the first atom in the compound a metal or the ammonium polyatomic ion? If the answer to that question is yes, then it is an ionic compound. So you will use no prefixes. And you will use Roman numerals for multivalent metals. Also, when building an ionic compound from a name, you have to make sure that you balance charges. If your answer to the first question was no, and that means that the first atom must be a nonmetal, then it's a molecular compound. And if you have a molecular compound, now you need to use prefixes to indicate numbers of each atom. There's a lot of good naming practice that I'd encourage you to try on this table that extends into the next page. In the next lesson, we will talk about, actually this extends for a while, doesn't it? There's some good multiple choice as well. And in the next lesson, we'll talk about solubility of ionic compounds.